At 4,000 meters, the air still contains 21% oxygen, yet your blood saturation plummets because your body runs on pressure, not percentage.
Many climbers fundamentally misunderstand thin air. The oxygen concentration at Everest Base Camp is exactly the same as at sea level, 20.9%. The problem is a systems engineering failure governed by Dalton's law.
Your lungs rely on a pressure gradient to drive oxygen across the alveolar membrane. As barometric pressure drops, the driving force, partial pressure of oxygen, weakens, starving the hemoglobin despite available air.
This pressure drop triggers an unavoidable performance penalty. Above 1,500 meters, you hit the VO2 Max Cliff. Regardless of your training, you lose roughly 10% of your aerobic capacity for every 1,000 meters gained.
Your immediate biological countermeasure is hyperventilation. Chemoreceptors in the carotid arteries detect low oxygen tension and force the diaphragm to work harder, blowing off CO2 to increase oxygen intake.
This changes your blood chemistry instantly, but true acclimatization is a slow manufacturing process. The kidneys secrete erythropoietin, EPO, signaling bone marrow to produce more red blood cells. This creates a new risk, polycythemia. Your blood becomes sludge-like, increasing strain on the heart and risk of frostbite due to poor circulation in extremities. It is a calculated trade-off your body makes for survival. If you ascend faster than this process occurs, you risk AMS. This isn't just a headache, it's mild cerebral edema. The lack of oxygen causes capillaries to leak fluid into the brain tissue, increasing intracranial pressure. The protocol climb high, sleep low isn't folklore, it's pressure management. You expose the body to the hypoxic stressor to trigger the EPO response, then descend to higher pressure to allow quality sleep and protein synthesis.
When protocols fail, we use chemistry. Acetazolamide, Diamox, is a carbonic anhydrase inhibitor. It artificially acidifies the blood by forcing the kidneys to excrete bicarbonate. This metabolic acidosis tricks your respiratory center into thinking you have excess CO2. This forces you to breathe deeper during sleep, eliminating the dangerous periodic breathing cycle that causes hypoxemia at night.
Here is the critical data point. Aerobic fitness has zero correlation with AMS susceptibility. A marathon runner is just as likely to develop cerebral edema as a sedentary smoker. It is genetic roulette.
Treat altitude as a manageable risk factor, not a fitness test. Monitor your SpO2 trends, stay hydrated to manage viscosity, and never ascend with symptoms. The mountain is a physics problem, not an ego problem.
Respect the physics of pressure, or biology will fail.